Chapter 4.1 Angles and Angle Measures in Degree and Radian. Recall from Math 20-1 that an angle in standard position means that the vertex of the angle is at the origin, the initial arm is lying along the positive x-axis, and then we have a terminal arm. Then when we rotate counterclockwise between the initial arm and the terminal arm, we get our angle theta. In 20-1, we only ever rotated counterclockwise and had positive angles, but now we're going to also include rotating clockwise, in which case we get a negative angle measure. Whichever direction you're rotating, your initial arm is always on that positive x-axis. To this point, we've only measured angles in degrees, but there is another type of measurement for angles called radians. We know that one full rotation around a circle is 360 degrees, and that is equivalent to 2 pi radians. Half a rotation, so halfway around the circle, is 180 degrees, and that is equivalent to pi radians. Let's complete the chart below. 360 degrees is one rotation. How many radians is that? It says up here one full rotation is 360 degrees or 2 pi radians. So 2 pi. 180 degrees is a half a rotation. How many radians would that then be? Well, if we take the full rotation of 2 pi and multiply it by 1/2, we get pi radians. 90 degrees around the circle, rotation of 90 degrees, that would be here, that's 1/4 of a rotation. Then how many radians would it be? Start with 2 pi, that would be a full rotation, times it by 1/4, we get 2 pi over 4, which simplifies to pi over 2. 60 degrees, how many rotations is that? 60 times 6 would be 360 degrees, so it's 1/6 of a rotation. So to get the radians, multiply 2 pi, a full rotation in radians, by 1/6, which would give us 2 pi over 6, which would simplify to pi over 3. 45 degrees, that would be 1/8 of a rotation, since 45 times 2 is 90, and 90 degrees was a quarter rotation. Then to get the radians, start with a full rotation, 2 pi, times it by 1/8, which gives us 2 pi over 8, which reduces to pi over 4. 30 degrees is half of 60 degrees. 60 degrees was 1/6 of a rotation, so 30 degrees would have to be 1/12 of a rotation. Then calculate the radian measure of 30 degrees. It's 1/12 of a rotation, so 2 pi times 1/12 is 2 pi over 12, which reduces to pi over 6. 1 degree, how many rotations is that? We have 360 degrees in one rotation, so that would be 1/360th of a rotation. Calculate the radians on that. 2 pi is a full rotation. Multiply it by 1/360 would be 2 pi over 360. That would simplify to pi over 180. A note here, an angle in radians can be written with or without units, i.e. pi rad for radians, or just pi. If no units are indicated, this means the measurement is in radians. An angle in degrees must be written with the degree symbol. This is really important information for you to know, because you're going to have to switch back and forth between radians and degrees, which includes switching the mode in your calculator. So you need to be able to identify which angle measurement you're using for that question. Converting between degree and radian measure. If we know that 180 degrees equals pi radians, then we can set up a ratio and convert between the two measures. So our ratio would be 180 degrees over pi, or pi over 180 degrees, whichever one suits our situation. Example, convert each angle to radians, and we want to give our answer in exact values. We're going to set this up as a proportional reasoning question, and then we're going to cross multiply and divide. We want to know how many radians is 120 degrees, so x radians on the bottom is equal to, our second ratio comes from up here where we said 180 degrees equals pi radians. In this case, I want degrees on top, 180 degrees, and radians on bottom. Next, we cross multiply and divide. We want exact values, so we're not going to calculate anything. We're just going to go 120 degrees times pi divided by 180 degrees, and then we want to simplify. (120) divided by 180 equals, change it to a fraction, math, enter, enter, 2/3. So 120 degrees is equal to 2 pi over 3 radians. And again, we don't have to write the units for radians. If we just write 2 pi over 3, then we know it's in radians because there is no unit written. Next one, 300 degrees. Same situation. We want to know how many radians is that. So put it over x radians is equal to our ratio 180 degrees on top, because we have degrees on top on the left, over pi radians on the bottom. Cross multiply and divide. We get 300 degrees times pi over 180 degrees. Simplify the 300 divided by 180. 300 divided by 180, enter, math, enter, enter, gives us 5 over 3, and degrees divide out, so we have 300 degrees is equal to 5 pi over 3 radians. Or we can use the units of measure to solve by remembering the following. Since 1 degree is pi over 180 radians, we can convert between degrees and radians as follows. To go from degrees to radians, multiply your number by pi over 180, and to go from radians to degrees, multiply your number by 180 over pi. You're essentially doing the exact same thing in both methods, so whichever way you think about it. Example, convert each angle to radians and give your answer in exact values. We're going from degrees to radians, so we're going to multiply by pi over 180 degrees. That gives us 150 degrees times pi over 180 degrees. And then again, we simplify 150 divided by 180 equals, math, enter, enter, 5 over 6. So we get 150 degrees is equal to 5 pi over 6 radians. Negative 270 degrees, going from degrees to radians again, multiply by pi over 180 degrees. We get negative 270 pi over 180. Negative 270 divided by 180, enter, math, enter, enter. We get negative 3 over 2. So negative 270 degrees is equal to negative 3 pi over 2 radians. Convert each angle to radians, round to the nearest tenth this time. We're going to radians again, so we're multiplying by pi over 180, but this time we're not writing our answers in exact values, so we're actually going to calculate. So negative 20 times pi divided by 180 gives us negative 0.349. 0 dot dot dot, and round to the nearest tenth is negative 0.3 radians. And again, if I saw this angle measurement, because it does not have a degree symbol, I know immediately it's in radians. 360 degrees to radians, multiply by pi over 180 degrees. This time we're rounding, so we are actually putting in 360 times pi divided by 180. 6.2831 dot dot dot. Round to the nearest tenth, we get 6.3 radians. Convert each angle to degrees to the nearest tenth where necessary. 7 pi over 6. Here we want to multiply by 180 over pi. So if we're converting from radians to degrees, we put the degrees on top. 7 pi over 6 times 180 degrees over pi. We can divide out these pi's before we multiply. Then we have 7 times 180, which is 1260. So we get 1260 degrees, because it was 7 times 180 degrees, over 6. 1260 divided by 6 is 210. So it equals 210 degrees, and I need to put the degree symbol, otherwise I would be saying 210 radians. Last one, negative 1.2. This is in radians. I know that because there's no degree symbol, so it has to be in radians. I'm converting to degrees, so I want to multiply by 180 degrees over pi. There isn't a pi in the radians to divide out, so we'll just put this in our calculator. Negative 1.2 times 180 divided by pi. This gives us negative 68.7549 dot dot dot, which gives us negative 68.8 degrees. And just to reiterate, we must have units for degrees. The principal angle is the smallest positive rotation angle. So in degrees, it's greater than or equal to 0 and less than or equal to 360. Or in radians, P is greater than or equal to 0 and less than or equal to 2 pi. The reference angle is the positive angle denoted as theta r that is formed with the terminal arm and the closest x-axis. Theta r is greater than or equal to 0 degrees and less than or equal to 90 degrees. Or for radians, theta r is greater than or equal to 0 and less than or equal to pi over 2. Here's a diagram of reference angles in quadrants 1, 2, 3, and 4. So this is quadrant 1. In quadrant 1, the reference angle is equal to the principal angle. This one is quadrant 2. In quadrant 2, to calculate the reference angle, we take 180 degrees, which would be all of quadrants 1 and 2, and we subtract the angle theta. That leaves us with the reference angle theta r. This one is in quadrant 3. To calculate the reference angle in quadrant 3, we take the angle theta, the principal angle, and we subtract 180, the angle of the first two quadrants. Then we're left with theta r. And last one, this is in quadrant 4. And to calculate theta r in quadrant 4, we start with a full rotation, 360 or 2 pi, and we subtract our principal angle, and then we're left with our reference angle, theta r. Coterminal angle is an angle in standard position with the same terminal arm. Example, 60 degrees and 420 degrees. So if we draw 60 degrees, it's about here. (420 degrees is more than one full rotation. If we go around one rotation, that would be 360. And then to get to 420, 360 to 420, that's another 60. So it would get back to this terminal arm that we had, and that would be 420 degrees. Then 60 degrees would be the principal angle, because it's between 0 and 360. And then 420 degrees is a coterminal angle, meaning that the terminal arm is in the same location as angle 60 degrees. General form of coterminal angles. An infinite number of coterminal angles can be determined by adding or subtracting any number of full rotations. The general solution is P, which is the principal angle, plus or minus 360 degrees times n, where n is an element of the natural numbers being the counting numbers 1, 2, 3, 4, or for radians, p the principal angle plus or minus 2 pi times n, where n is an element of the natural numbers. Example, for each angle in standard position, determine one positive and one negative measure that is coterminal with it. We start with 270 degrees. So to get a coterminal angle that's positive, we could add 360 degrees. And to get a negative coterminal angle, we could subtract 360 degrees. 270 degrees plus 360 degrees equals, let's bring up our calculator, 270 plus 360 gives us 630 degrees. Then 270 degrees minus 360 degrees to get our negative coterminal angle. 270 minus 360 is negative 90 degrees. Next is radians, negative 5 pi over 4. For radians, we want to add or subtract 2 pi. Starting with adding, negative 5 pi over 4 plus 2 pi. If we want to write that with a denominator of 4, multiply 2 pi by 4, we'd get 8 pi over 4. Then negative 5 pi plus 8 pi is 3 pi over 4. And for subtracting, we have negative 5 pi over 4 minus 8 pi over 4, which gives us negative 13 pi over 4 radians. Next one, 740 degrees. If I add 360 degrees, I'll get a positive coterminal angle with 740. But if I subtract 360, I'll still have a positive number. So let's do the positive first, get that out of the way. 740 degrees plus 360 degrees gives us 740 plus 360 should be 1100. 1100 degrees. Then for subtracting, I can just use my calculator. 740 minus 360 is 380, so that's still a positive. If I subtract 360 from that, it's still a positive. I subtract 360 from that, and there we get a negative. So how many times did I have to subtract 360 before I got a negative? 3 times. So what I'm doing is 740 degrees minus 360 degrees times 3, and that gave us negative 340 degrees. Write an expression for all possible angles coterminal with each given angle. Identify the angles that are coterminal that satisfy theta is between negative 360 degrees. Identify the angles that are coterminal that satisfy theta is greater than or equal to negative 360 degrees and less than or equal to 360 degrees. Or for radians, theta is greater than or equal to 2. Or for radians, theta is greater than or equal to negative 2 pi and less than or equal to 2 pi. Looking back at general form that was up here, we write it as P, the principal angle, plus or minus 360 degrees times n, or P plus or minus 2 pi times n. So depending if it's radians or degrees. First one is degrees. The first one is degrees, negative 500 degrees. We would write for the general form for the general form, we want to write plus, minus, for the general form, we want to write plus, minus 360 degrees times n, where n is an element of the natural numbers. Write an expression for all possible angles coterminal with each given angle. Identify the angles that are coterminal that satisfy theta is greater than or equal to negative 360 degrees n less than or equal to 360 degrees. Or for radians, theta is greater than or equal to negative 2 pi and less than or equal to 2 pi. First one is negative 500 degrees. Taking a look back at our general form of coterminal angles, we write it as the principal angle plus or minus 360 degrees n where n is. Taking a look at general form of coterminal angles, we write them as P, the principal angle, plus minus 360 degrees n, where n is an element of the natural numbers. Or for radians, P, the principal angle, plus minus 2 pi times n, where n is an element of the natural numbers. Then the first thing we would need to do is determine the principal angle. Remember, the principal angle is the smallest positive angle, and it's going to be for degrees greater than or equal to 0, less than or equal to 360. So negative 500 is not the principal angle. Let's subtract 360 degrees. Let's add 360 degrees. In our calculators, let's add 360 degrees and see what we get. Negative 500 plus 360. We know it's still going to be a negative because negative 500. We know it's still going to be a negative. Let's see what we get. So negative 140. We need to add another 360. And then we get our smallest positive. And then we get our smallest positive angle. This would be our principal angle. Write an expression for all possible angles coterminal with each given angle. Identify the angles that are coterminal that satisfy theta is greater than or equal to negative 360 degrees and less than or equal to 360 degrees. Or for radians, theta is greater than or equal to negative 2 pi and less than or equal to 2 pi. Starting with the expression for all possible angles coterminal with each angle, if we take a look back at our general form, we had P plus or minus 360 n, where n is an element of the natural numbers, or P plus or minus 2 pi n, where n is an element of the natural numbers. This was for the principal angle. We can modify this for any angle by writing theta plus or minus 360 degrees n, where n is an element of n. Or for radians, theta plus or minus 2 pi n, where n is an element of n. That's what we'll use here. And we're doing this because negative 500 degrees is not the principal angle, since it's less than 0 degrees. Then the general solution for negative 500 degrees would be plus or minus 360 degrees n, where n is an element of n. Let's do the general solution for all three before we move on to the next part. 650 degrees plus minus 360 degrees n, where n is an element of the natural numbers. And then the next one is in radians, 9 pi over 4, so plus minus 2 pi n, where n is an element of the natural numbers. The next part of the question wants us to identify the angles that are coterminal that satisfy for degrees. The angle is greater than or equal to negative 360 degrees and less than or equal to 360 degrees. So it's saying one full rotation in the negative direction and one full rotation in the positive direction. Negative 360 degrees is less than or equal to theta is less than or equal to 360 degrees. Our angle, negative 500 degrees, is already smaller than negative 360 degrees, so we definitely have to add negative 500 degrees plus 360 degrees. Bring up our calculator again. Negative 500 plus 360 is negative 140. Is that greater than or equal to negative 360 degrees and less than or equal to 360 degrees? Yes, it is. So it is one of our coterminal angles that satisfies this. And then what if we add another 360? Do it in our calculator. Plus 360, we get 220, which is also greater than or equal to negative 360 and less than or equal to 360. So negative 500 degrees plus 360 degrees times 2 equals 220 degrees, which also satisfies the requirements. If we add another 360, would it still be between negative 360 and positive 360? No, because if we add 360 to 220, it's going to be more than 360. So these would be our only two angles that will satisfy the restriction for theta. Same idea for the next one. Again, our restrictions for theta is negative 360 degrees is less than or equal to theta, which is less than or equal to positive 360 degrees. Our theta is already more than 360 degrees, so we're going to need to subtract. If we subtract 650 minus 360, we get 290. So that is less than 360 degrees and greater than negative 360 degrees. So it satisfies our restriction on theta. 650 degrees minus 360 degrees equals 290 degrees. Then if we subtract 360 again, we get a negative. It's negative 70, so 650 degrees minus 360 degrees times 2 gives us negative 70 degrees, which is greater than negative 360 degrees and smaller than positive 360 degrees. What if we subtract 360 again? Would we still be greater than or equal to negative 360? No, we wouldn't. If we went minus 360, we get negative 430, which is outside this restriction for theta. So these two angles are only coterminal angles in that range of values for theta. Last one is in radians. It's 9 pi over 4. Our restriction is negative 2 pi is less than or equal to theta is less than or equal to 2 pi. Our angle, 9 pi over 4, is already bigger than 2 pi. 8 pi over 4 would equal 2 pi, so this is already greater than 2 pi. So we're going to need to subtract. 9 pi over 4, subtract 2 pi, can be written as 8 pi over 4. And that gives us 1 pi, or just pi over 4, and that value is greater than negative 2 pi and less than positive 2 pi, so it is one of our coterminal angles in this restriction. And then if we subtract 8 pi over 4 again, we would get a negative value, so 9 pi over 4 minus 8 pi over 4 times 2. 8 pi over 4 times 2 would be 16 pi over 4. 9 minus 16 would be negative 7. So we get negative 7 pi over 4, which is greater than negative 2 pi and less than 2 pi. So it's within our restrictions for theta. Arc length. A radian is the measure of the central angle subtended in a circle by an arc equal in length to the radius of the circle. We can go back to the first page of our notes to get a better idea of what this is saying. Here we have a circle, and we have an angle theta created by an initial arm that is length r, the radius of the circle, and a terminal arm, which is also length r, the radius of the circle. So theta is our angle, and then A is the portion of the circumference of the circle that is between the initial arm and the terminal arm. And what this statement that we just read is saying is that when the arc length A is equal to the radius, that gives us an angle measure of 1 radian. Then we have the formula radian equals arc length over radius, or theta equals A for arc length over r for radius. The theta in this equation is always radians. So if you're doing a question, you need to make sure that your angle is in radians before you use this formula. And this equation is on your formula sheet. And we'll draw a diagram. Say we have an angle here, our initial arm there, that are the same length. This is our A, our arc length, our theta here, this is r, and this is r. Example, an arc of 14.6 centimeters has a central angle of pi over 4 radians. Determine the radius of the circle to the nearest tenth of a centimeter. Start with our formula. Theta equals A over r. Then plug in what we know. Our theta is pi over 4. Pi over 4 equals, the arc is 14.6 centimeters, and we don't know the radius, so we'll leave that as r. And then we can just cross multiply. We have two fractions equal to each other. So 4 times 14.6 divided by pi. Four times 14.6 divided by pi gives us 18.5892. And then it says to round to the nearest tenth. So r equals 18.6. And what units would it be? It said the arc length was in centimeters, so the radius would be in centimeters. If A represents the length of an arc of a circle with radius r, subtended by a central angle of theta, determine the missing quantity. Give your answers to the nearest tenth. For A, we have r equals 8.7 centimeters and theta equals 75 degrees. We want to find A. Notice our theta is in degrees. We need to convert first. our theta has to be in radians before we can use the theta equals arc length over radius formula. I have 75 degrees. I want to know how many radians that is. I know that 180 degrees is pi radians. Cross multiply and divide. I get 75 degrees times pi over 180 degrees. 75 divided by 180, math, enter, enter, is 5 over 12. So 5 pi over 12 radians. Now I can use my formula. I have theta equals A over R. Theta is 5 pi over 12 equals A over a radius of 8.7. Cross multiply and divide. 5 pi times 8.7 divided by 12. We get A equals 11.3882. So A equals 11.4 to the nearest tenth. And what units? Radius is centimeters, so this is centimeters. B, A equals 4.7 millimeters, theta equals 1.8, find R. Looking at our theta, it has no units, so we know it's in radians. We can go right into our formula then. Theta equals A over R. Theta is 1.8 equals A is 4.7 divided by R, which we don't know. I can put a 1 underneath here and then cross multiply and divide. 1 times 4.7 is 4.7, then divided by 1.8 gives us 2.6111. Then R equals 2.6 rounded to the 10th, and the unit would be millimeters. C, R equals 5 meters, A equals 13 meters, find theta. Theta equals A over R. Theta equals 13 over 5. 13 divide 5 gives us 2.6, so theta equals 2.6 or 2.6 radians. Last question. A pendulum is 40 centimeters long. If the end of the pendulum swings through a total distance of 13.5 centimeters, what is the measure in radians and in degrees, both to the nearest tenth, of the angle through which the pendulum swings? So the pendulum is 40 centimeters long. That would be our radius. And the end of the pendulum swings through a total distance of 13.5 centimeters. That would be our arc length. We want the angle in radians and degrees. Starting with radians, theta equals A over R. Theta equals 13.5 over 40. 13.5 divide 40 gives us 0.3375. Rounded to the nearest tenth, theta would be 0.3 radians. And then we'll change that to degrees. 0.3375 over theta, our unknown angle in degrees, is equal to, we know pi radians is 180 degrees. Fractions are matched in order, so radians are on top, degrees are on bottom. Cross multiply and divide. 180 times 0.3375 divided by pi. We get 19.3373. Rounding to the 10th position, we get theta equals 19.3 degrees. That brings us to the end of Chapter 4, Lesson 1.